Okay, now taking some questions. Let's take number one, the first question. And I read, a pipe 40 meters long. A pipe 40 meters long is connected to a water tank at one end and flows freely in the atmosphere at the other end. I have already drawn the diagram here. This is the water tank, and this is where it flows freely. So a pipe 40 meters long, total length is 40 meters. The diameter of the pipe is 15 centimeters for the first 25 meters. So for the first 25 meters of the pipe, that is from here to here, the diameter is 0.15 meters. And for the from the tank, and then the diameter is suddenly enlarged to 30 centimeters. That is this 0.30 meters. Note, we are converting centimeter to meter. We won't use it like that because we have to ensure uniformity in our units. Height of water in the tank is 8 meters above the center of the pipe. Height of water in the tank is 8 meters above the center of the pipe. We can see it's already drawn there. And then Darcy's coefficient is 0.01. Darcy coefficient F is 0.01. The question says determine the discharge neglecting minor losses. Note, neglecting minor losses means like neglecting shock losses that I explained above, but we are not going to explain that. So now let us see how we can quickly solve this question. Let me scroll that up. Okay, let me go back to the diagram. This is the diagram now. We have the diameter of the pipe, we have the length, we have the diameter of the second pipe too, we have the length, which are joined together. Which kind of network is this? Is it parallel or series? Series. This is a series connection. This is a series connection. Therefore, this is a series connection. Therefore, we are going to add. So that means that the total head loss HL will be equal to HF1 plus HF2. That's the friction loss in pipe 1 and friction loss in pipe 2. So what is our formula for HF? The general formula, we have two kinds, right? So the first one is HF is equal to 4FL over D multiplied by V1 square, V over 2G, V square over 2G, not V1, sorry. So now, but do we use this formula? What do we have to find? We have to find the discharge. I think it will be more convenient to use the formula that involves Q, that is discharge, and that is HF is equal to 32 FL Q square over pi G square D raised to power 5. These are formulas. You just have to know them, at least for the time being. If you don't know how to prove them, you just have to know them. This is the same thing as this. So if it was that we have to find velocity or something now, I would have used this because it will be easier. But since we have to find discharge, Q, I think that using the formula that contains discharge will be the best. So now, what is our HL? Remember I told you that HL is the difference in this length, that is 8 meters. So we have 8 will be equal to HF1. So now let us bring up the formula. that's 32 F1 L1 Q square over pi G square D raised to power 5 D1 plus 32 F2 L2 Q square over pi g square d2 raised to power 5. Remember, this is a single flow, so for continuity of flow, like let's say this is q1 and this is q2, for continuity of flow, q1 will be equal to q2, that is the discharge here, q1 will be equal to the discharge here, q2, because fluid is neither created nor destroyed. So if q1 is equal to q2, then that is simply q. Oh, I'll write that again. That is simply q. So let me just q. And now let us move on. Okay, let us collect like terms so that we can solve this equation. We can factorize q. A to be equal to q square. Let's factorize out all the common things, or not. Let us just factorize out q square. Q square into bracket 32 f1 l1 q square over pi g square d1 raised to power 5 plus plus 32 f1 f2 l2. Did I put q again? I'm sorry, q is not supposed to be there. So l2 over pi g square d2 raised to power 5. And simply let us put in the things that we know. 8 is equal to q square into bracket 32 times, what is f1? Note they were given the density coefficient for both pipes, so that means f1 and f2 are equal. So that is f1, which is 0.01. Then l1 is what? 25 meters over pi times g 9.81 square times d1 is what? 0.15 raised to power 5 plus 32 into bracket 0.01 multiplied by the length of the second pipe is 15. How did we get 15? The total length is 40 and the length of the first pipe is 30. So the length of the first pipe is 25. So 40 minus 25 gives us 15. So that is the length of the second pipe. Then over pi 9.81 square times, what is that is 0.3 raised to power 5. Then we close the bracket and we have 8 is equal to q square into bracket. Now let us resolve this. 1088.09 plus 64.09, and let me scroll down. So q square will be equal to 8 divided by the summation of those two, which is 1152.18, and q square will now be equal to 6.943 times 10 raised to power minus 3, and q will be equal to square root of that's 0.083. And what is the unit? Is discharge, so it's meter cubed per second. And we will see that that is the solution here too. So I'll be solving the next question, another question, in the next video.